Welcome to another instance of my vlog. I'm gonna talk about my UI, what I've been working on it, and how I'm doing state transitions and animations. First, should talk about a bit more how my UI is structured at all. It's all centered around a concept of a scene, which contains what is the wrong error? Things called primitives. And that is rendered by a renderer of some sort. And in my case, that is WebGPU right now. But it could be anyone. There is no need for the scene to care about what it is rendered by. The renderer just needs to be able to understand these primitives. And my UI, a UI element, has two functions. It has a layout function and a draw function. The layout function we'll talk about in a second, but when you call draw, you supply, it constructs the scene object here. And that gets then rendered later on. We can look at it in code in a second. And the layout does what the name suggests. It lays out the UI. And it's in two separate passes for reasons I don't really want to get into. But mostly it just simplifies it, separation of concerns, yada, 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 all that nonsense. If we go and to my render loop somewhere, it exists here. Then we can see that I'm creating a context. That is just necessary information we need for rendering, such as some cache, and it uses it to construct hitboxes, etc. Not going to go into that right now, but we see that we call layout on the UI with size constraints. We're gonna talk about this in a second, and then we're drawing it with the size that it of the screen. Here. We ignore the size it returns, which we maybe shouldn't be doing. Because there's some invariants that we need to honor. Because there is an invariant, and that is that the state does not change between them, and that you do get drawn in the size that you reported that you want to be drawn in. So, okay, let's talk about that. So, an element, when it gets called for layout, has a parameter of the constraints. And it outputs a size. It's stateful and it can mutate itself in the meantime, but a constraint basically is how much space you have. And the size is what space it actually wants to take. There's some finer details there that I'm not gonna go into with infinitely expanding layouts versus layouts that have a concrete size. For example, a scroll area would have, it would always try to take as much space as possible. It has no size constraint because you could just always scroll more. Whereas a text field doesn't really do that. And draw itself is relatively boring. Oh, we are looking at the wrong thing. Let's look at padding. This is simple. This is a simple element. Here. So here we have padding. And we can see that when we lay out, it just takes the padding parameters is just a pad left, pad right, pad top, pad bottom. Nothing exciting. It takes the constraints and then figures out what the additional space that we need from the for the child, and then we simply remove this from our max constraints. So a constraint has min size, max size, and a screen size. If something just wants to be the size of a screen, for example, as a reference. So we reduce the max size by the amount we're padding. But we're not going below 0. That's the weird way I'm wrote here. One can do it differently, but that's fine. Same for the min size, but with the min size, yeah, same for the min size. And then the child sorry, then the child size simply becomes whatever the layout of the child spits out with those constraints, and then we report our the child size plus the padding spaces as our size, and we're gonna clamp it to the constraints because there's one invariant, that is, we're never allowed to be smaller than the min size and never larger than the max size, and that's what clamp to constraint does. It makes sure that this never escapes the bounds. And when we're drawing, we simply draw ourselves. And now we get something extra that is an origin. So when we lay out, we don't know where on the screen we are. That is irrelevant for the layout. Maybe it might become relevant later. I'm not sure, but for now it's completely irrelevant where on the screen we are. And in exchange, when we draw, we get a origin supplied to us. And then for padding, the origin is offset by pad left and pad top. The size, again, we adjust it by the padding, and that's it. We don't care about padding bottom and padding right, because that just happens automatically. I believe my text input is already padded, if it starts. Yeah, you can see that there's a padding in my text field here. And we get the state from a state to param transformer here, which is just a function that takes in a state in an instant that is a time and supplies the parameters. And that does allow us to do things like animation. If we go and find our padding here. Right now, our text input has a uniform padding of 5, but we could do an animation controller for padding parameters. Let's start also with uniform 5. Let's have it reference counted. And then in here, and I can go into how animation works in a second. We need to also configure our animation. Let's quickly do that. Update state. We need a target value. I don't know. some values. State dot state, we need an easing. I will explain how any of that works in a second. Progress. Let's do a ping pong progress and let's define a duration. That is 1 second. Let's go for 5 seconds. And if I restart this, we should now see the padding changing. No, we shouldn't, because I haven't done this. That is the animation controller. And we can see that it does now indeed animate the padding value. We can do that with any element we want. The animation is not part of the UI itself because it gets applied from the state on the outside. We could also make animation elements that would transform parameters and feed them downwards. But that nicely separates them from each other, and the way animation works itself is simply there is a trait called interpolatable, which just means we can interpolate between it. Interpolation means in this case linear interpolation. That's why we have the easing. Easing allows us to change it from linear to anything we want. The predefined ones are linear, ease in quad, ease out quad, is in and out quad, and that's why we see it. I closed it already. So if you look at it, we can see it speeds up and slows down as it gets to the borders. That's what it just means. We can supply any custom ones as long as it stays between 0 and 1. And then there's a progress for it. Progress here. And ping pong just means what we just see, that it just repeats the animation forwards and backwards. Repeat would repeat it X amount of times. Loop would just loop infinitely from start to end. And once is self-explanatory. And custom, we can again define whatever we want as long as the output remains between 0 and 1. Yeah, and if easing is applied first, and progress is first calculated, and then easing is applied to that value in that order. And then there's a lot of magic with a trait macro here, which needs to be cleaned up. But it allows us to make any structure interpolate. Oh my god, I hate this word. Interpolatable. I don't know why it's that difficult, but if we look at padding parameters, then we see that we're deriving interpolatable for it, which is why we can directly call animation controller value on it, which does the interpolation. Let's interpolate here. This trait is a bit... this macro is a bit more complex. It's allows us to... It is applied recursively to structures. So as long as every value is interpretable within it, then the thing itself is as well. There are some special cases like strings. You can't interpolate strings, so we knock them out. In optionals, there what do you do with an optional? Like in none is not really a value you can interpolate. I have for now defined that you can define specify a custom value, or that you can just use the default value if there is one. Others that are reasonable are, for example, like a pop in or a pop out. So then when the progress reaches the full, like 1, then it appears, or if the progress goes away from 0, then it disappears, stuff like that, or at the halfway point. You could define a whole bunch here. You could even define functions in here if you really wanted to. But I'm not going to explain how this macro works on a concrete level. If you're interested, you can read it. It's in the repo. But I just don't want to go into proc macros for Rust right now. Yeah, and that allows us to do all the things we want in regarding to animation. Now, origin is not, we can't animate the origin yet, but we could easily create a UI element that controls the origin of a subfield of an element, like positioning UI element, and then animate its parameters, and then you would have animated origins, and you could do it relative to screen or relative to its own easily. Is there anything else to say? No, that's the main thing I've been working on. Still working on the framework itself, trying to figure out a reasonable way of getting state. State. And state just gets supplied from a state object that you can pass in. It can be anything. And you pass in a function that gets it from that object. In this case, we are not using that object. We could, since we are using static functions right now, but we could bind this to things. One thing I haven't figured out yet is dynamic UIs. That is when we want to change the UI tree dynamically. It's fixed right now. We could create elements that, based on some conditions, would switch between them, or dynamically create more elements and drop them again. I'm not sure how I want to handle that reasonably. There's another option thing that's open still, and that is event management, or rather state updates. Right now they're driven through something called an event manager, sort of, kinda. It's not really an event manager, it just detects hitboxes. So there's still quite a bit of fiddling I want to do. But all of that has time. Next time I'm going to be working on a UI for a character sheet, maybe. And from there, go deeper into virtual tabletops. See you around.